Hello, my bomb blowers and module masters, and today I am here with another Keep Talking and Nobody Explodes, a modded module tutorial, and today I am here with the module Boolean Network. Boolean Network is a module about iterating a sequence through 3 generations, and we're going to be utilizing some Boolean values. Let's go ahead and get started. This module does not require any edge work, so as soon as we get our bomb, we can get started.
There is only one
So,
perfect solution.
here's Boolean Network.
That will try to trick our team.
It has 6 different buttons, all with either white or black outlines, and an ungodly mess of arrows. What in the world is this, you may be asking? We'll get there when we get there. So, first thing I'm going to make clear is that I have this template here that helps me a lot while doing this module. The letters A, B, C, D, E, and F are referring to the 6 buttons in clockwise order. So this is A, B, C, D, E, and F. So the first thing we're going to do is write down the states of the 6 buttons, which are determined by either a white outline or a black outline. If the button has a white outline, such as this one, then its starting state in iteration 0 is going to be a 1. If it has a black outline, then the state in iteration 0 is going to be a 0. So let's get our states. We have 1, 1, 1, 0, 1, 0. And to make it clear, I'm going to just label the columns. Next, in front of the letters I have down here, I'm going to write the colors of the buttons. So they are green, blue, red, blue, red, blue. And now I'm going to write down the arrows. I'm going to write these down in a very specific fashion. I'm going to start from the A button, and I'm going to look at all of the arrows that point at the A button. If the arrow has a pointed tip, that means I'm just going to write the name of the button that is pointing to this button that we're looking at. But if the arrow is flat, then I'm going to write not the button that is pointing towards this button. You'll see what I mean when we get to B. So first off, let's write down all of the arrows pointing towards A. We have this one, which belongs to E. This one, which belongs to D. This one, which belongs to C. And this one, which belongs to B. For B, we have this one, which belongs to E. However, it has a flat tip, so this is actually not E, which I'm going to represent by an exclamation mark. And then also C is pointing towards B. With C, the only arrow pointing towards it is not F. With D, the only one pointing towards it is B. For E, only one pointing towards it, that's not D. And finally, with F, we have A pointing towards it and not B pointing towards it. Now, we're going to do an iterative process 3 times. We're going to take the color of the button that we're looking at. So we're going to start with looking at A. And we're going to look up its color here. Its value in the generation that we're currently working on is equivalent to whatever the color says. So the value of A is going to be 1 if at least one of its inputs is a 1. Otherwise, it's a 0. So A is going to be 1 if either E, D, C, or B are a 1 in the previous iteration. As we can see, B, C, and E are all 1s. We only needed one of them to be a 1. So that means that A is going to be a 1 in the next generation. Next, we're moving on to Bravo, which is in blue. The value is 1 if the majority of inputs are a 1, otherwise it's 0. So the majority of the 2 inputs, the inputs are the buttons that are pointing towards the button. So for A, the inputs are E, D, C, and B. And for C here, the input is just not F, because that was the only button pointing towards it, and the arrow was a not arrow. So for B, the majority of 2 will be 2. Because if only one of the inputs is a 1 and the other one is a 0, then half of the inputs are a 1, which we're looking for more than half. So B is only going to be 1 to the next generation if both the opposite of E and C in the previous generation are both 1. So the opposite of E is 0, which already means that B is going to be a 0 in the next generation. Next we have C, which is red. Red means that the value is 1 if all of the inputs are 1, otherwise it's a 0. So with C, there's just one input. So if this one input is 1, then C is going to be a 1. It's not F, so we're going to take the opposite of F's value from the previous generation, which is 0. The opposite is 1, so C is going to be 1. This doesn't really show off the effects of red, but if we pretended that A is red, for example, this is just a hypothetical scenario, then the only way that A is going to be 1 in the next generation is if all of E, D, C, and B are 1. As you can see here, D is not a 1. So if A's button was red, that means that A would have been a 0 instead. Additionally, let's pretend that A was blue. 3 out of the 4 inputs are 1. That is the majority. So if A was blue, then A would have been a 1. But A is green, so that's all we care about. Next, we're looking at D, which is assigned to just B. A tip I have is that if a button has only one input, then the state of the button in the next iteration is going to be the same as that input in the previous generation. So for D, its state is going to be equal to B in the last generation. B was 1, so D in this generation is going to be 1. Once again, we have a button with one input, which is not D. So E's state in the next generation is going to be equal to its only input, which is the opposite of D's state. The opposite of D is E, so E is going to be 1 in this generation. And then finally we have F, which is in blue. And if the majority of A and the opposite of B are 1, then F is going to be 1. The majority of 2 is 2. We have A is 1, but the opposite of B is 0, which means that F is going to be 0. We're going to do this for 2 more iterations, using the values for the 6 buttons in the previous generation. So let's do it again. A is going to be 1 if any of E, D, C, or B are 1. 3 of them are 1, so A is going to be 1 here. B is 1 if the opposite of E and C are both 1. The opposite of E is going to be 0, which means B is 0. C is going to be 1 if the opposite of F is 1, which it is. D is 1 if B is 1, which it is not, so D is now a 0. E is 1 if the opposite of D is 1. The opposite of D is 0, so it is not. And then F is 1 if both A and not B are 1. A is 1, and the opposite of B is 1, so F is 1. Finally, we're going to take the values of iteration 2, and we're going to use those with the inputs and operators to get values for iteration 3. A is 1 if any of E, D, C, or B are 1. C is 1, and that is enough for A to be 1 in this generation. B is 1 if both C and the opposite of E are 1. C is 1, and the opposite of E are both 1. C is 1 if the opposite of F is 1. The opposite of F is 0. D is 1 if B is 1. B is 0. E is 1 if the opposite of D is 1. The opposite of D is 1. F is 1 if both A and the opposite of B are 1. A is 1 and the opposite of B is 1, so F is going to be 1. Now that we have the result of the third iteration, it is now time to submit. To solve the module, you're going to press every button whose value is 1 in the third iteration. So for this module, it's going to be A, B, E, and F. And the module is solved. Now, I'm not sure if it actually will submit again. Let's test it out. Okay, so it doesn't. So, say we had misinputted. Say we were doing, oh, A, B... Oops, I pressed D. What do I do? Before the 2 seconds are up, you can press D again to make it come out of its press down state. So you can toggle as many buttons as you would like within 2 seconds of pressing the first button. Or pressing the last button. When it submits after 2 seconds has passed without a button being pressed. Let's go ahead and do the other one on the spawn as an additional example. Once again, I'm going to put the button labels up here for reference. Now, we have, in clockwise order, the colors of red, blue, blue, red, green, red. The states are 1, 0, 1, 1, 1, 1. And I forgot to actually do this correctly. And now we're going to look at the arrows. So what points to A? E with a flat tip, which is not E. C with a flat tip, which is not C. And then B with a pointed tip, which is B. Now what points to B? Not D. What points to C? Not B and E. What points to D? F and A. What points to E? Not B. What points to F? Not A and not B. Okay, so let's start the iterative process. A is going to be true if all of not E, not C, and B are 1. B is a 0, which automatically means that A is going to be 0 in the next generation. B is going to be 1 if not D is 1. Not D is 0, so B is going to be 0. When I say not a variable, I'm just saying it's 0 when it says it's 1, or it's 1 when it says it's 0. So C is going to be a 1 if both not B and E are 1. Not B is a 1 and E is a 1, so C is a 1. D is a 1 if all of F and A are 1. F and A are both 1. When I said all of not B and E, I really meant C is 1 if the majority of not B and E is 1. And the majority of 2 is still 2. The only time where B is different from R is if you have 3 or more inputs. Like so. For A, since it's red, all 3 of not E, not C, and B have to be 1 for A to be 1. But if A was green instead, only 2 of the 3 have to be 1 in order for A to be 1. Likewise with 4 inputs, A red means that all 4 have to be true, but A green means that only 3 have to be true. Anyway, let's continue on. E is true if at least 1 of not B is true. 1. Not B is 1, so E is 1. And then finally, F is 1 if both not A and not B are 1. Not A is 0, so F is going to be 0. Now we take the values of iteration 1 and perform the same operations to get the results of iteration 2. A is 1 if not E, not C, and B are all 1. B is still not 1, so this is going to be 0. B is 1 if not D is 1. Not D is 0. C is 1 if the majority of not B and E are 1. Not B is a 1, and E is a 1, so C is going to be 1. D is 1 if both F and A are 1. Neither of them are 1, so D is 0. E is 1 if the opposite of B is 1, which it is. And F is 1 if both the opposite of A and the opposite of B are 1, which they both are. Finally, For iteration 3, we're going to take the results of iteration 2 and do the same Boolean logic. A is 1 if all three of these are 1, but B is a 0, so A is a 0. B is a 1 if not D is a 1, which it is. C is a 1 if both not B and E are 1, which they both are. D is a 1 if A and F are both 1, A is not 1, so D is 0. E is 1 if not B is 1, which it is. And F is 1 if not A and not B are 1, which they both are. So for this, we're going to submit B, C, E, F. Oops, I pressed D, pressed it again, and it's no longer submitted. And that is a solved module. Thank you for watching, and have a nice day.